where k1 is equal to h into f of xn comma yn. This defines the value of k1. H term step size gives me the approximate y and exact y. Error then xk1, k2, k3, k4. Hello everyone, it is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In my previous session, I had discussed about Simpson's 1/3 rule. Now in today's session, let me explain about the Runge Kutta 4th order method. And of course, you need to be taught with Runge Kutta 2nd order method, then 4th order method. It is not problem if I explain the Runge Kutta 4th order now, because you need to have the knowledge of differentiation in the process of finding the solution. So if that is the case, Runge Kutta order 4 to find out the approximate solution of the initial value problem. The step size of 1, where h is equal to 1, we have an error of 0.1. That means an half of this. When h is equal to 2, we have 0.05. When h is equal to 3, we have 0.025. So calculate the error rate and tabulate the results. If that is the case, we have made table 7, 8, 9. So if you look at this table 7, you will see that the step size is 1.00, that is 0.1. What is the initial value? 0 and 1 are considered as the initial value. Then we have an approximate y, that is 1. Exact y, that is 1. What is the error? Exact y minus approximate y, that gives me the error. If that is the case, what is the value of k1, k2, k3, k4? How can we find out the values of k1, k2, k3, k4? If that is the case, we shall see how to find out the values of k1, k2, k3, k4. Where k1 is equal to h into f of xn comma yn. This defines the value of k1. Then what about k2? k2 is equal to h into f of xn plus h by 2 comma yn plus k1 by 2. As I have already determined the k1, this value is applied onto this and divided by 2 to get the value of k2. If that is the case, how can we find out the value of k3? That is, k3 is equal to h into f of xn plus h by 2 comma yn plus k2 by 2. This gives me the value of k3. I am using the k2 which is obtained in the previous step, that is this. The value of this is substituted into this to get the value of k3. As I have already obtained k3, let me find out k4. k4 is equal to h into f of xn comma xn plus h comma yn plus k3. This gives me the value of k4. I have obtained the value of k4 here. So using these formulas in the first iteration, I have obtained k1, k2, k3, k4. Now what is the error? In this case, it is 0.000. In the next case, that is in this case, initial value as 0.1, that is step size 0.1 here. If it is considered here, what is the upper limit? Y, that is 1.000. Then the step size again 0.1. 1.00 minus this term leads to this term, plus this term leads to this. So we have this 1.111110490. Then we have the exact y. This is the value we have obtained, exact y. Exact y minus approximated y will give you the answer. Error in it. Then again k1, k2, k3, k4 is obtained. Using k1, k2, k3, k4, we will initiate the next value, that is h. 0.2, initially 0.1, then 0.2, 0.3, 0.4, 0.5. If that is the case, what is the value of y? It is considered 490. This approximate y is considered as initial y here. Then we have 0.1 as the step size there. Then we have approximate y we have calculated, that is yn, that is what is the value of yn? Y is equal to f of xn. So if that is the case, what is the value of f of xn? That is going to determine the yn is this. Then we have the exact y here. Then exact y minus this leads to the error rate. Then similarly, using these formulas, k1, k2, k3, k4 is determined. That is, these values are obtained. And finally, we are going to get the value for the next iteration, that is 0.3000. For this, I am getting the value from here, that is 921. This is my initial value of y. Then we have a step size of 0.1. This is the predicted y. This is the approximate exact y. Then this is the error rate, k1, k2, k3, k4 using the formulas. Then we have obtained this term. This becomes my new value of y. This is my 0.4. The same procedure is followed for everything to get the value until the value of x is 0.5. When the value of x is 0.5, what is the value of y? That is the value of y which is taken from here. That is, the approximate y is taken as the initial value. Then the step size of 1 is considered, approximate y. Then we have an exact y there, then error rate, then we have k1, k2, k3, k4. This gives me the values of this. So this is my value and this is my xn and yn. For xn and yn, what is the value I have obtained? 1.83735686. So this is the value I have obtained. Similarly, for the step size of 0.050, for this, what is the value I am getting? Because the step size is 0.050, if I consider the step size is added to x 0 plus 0, that gives me this term plus ultimate upper bound, then plus this term h term, step size, gives me the approximate y and exact y, error, then x k1, k2, k3, k4. The same procedure is followed here. The only thing is you need to add plus 0.05 to this term to get the next term, that is the initial x. Then we will add up this term to this to get this term to this term. Then we will get 20. Then 20 to this term, step size, we will get this term. And what is the value of y? How I am getting the value of y? The value of y is obtained from this approximate y. So observe here, I am just showing you with an representation of arrow mark that how I considered this. How did I get this term? Approximate y. Of course, we have an exact y here. We have an error rate here. If I subtract this from this, I'll get the error rate. And of course, you are clarified with it. Then you have k1, k2, k3, k4. With this k1, k2, k3, k4, I am going to obtain the value of yn. That is this approximate yn using the Runge Kutta fourth order. Yn is equal to f of xn. Then what is xn? Suppose if I consider that x square minus 9 is the equation, f of x is equal to this, then what is y? Y is equal to x square minus 9. This is the formula. This is the function I am considering here. If that is the case, what is the value of k1? K1 is obviously known to you. F of xn comma yn. What is xn indicates? Suppose if I substitute the value of x equal to 0 there, I will get 0 square minus 9. Obviously, that leads to y0 equal to 0. Then similarly, that is how we are going to calculate. This procedure is followed to find out the value of yn and to predict the value of approximate error, that is approximate value of this with exact value. So what is the error rate we have obtained here? 0.102987768. So with this, I am going to say that this is the exact value. This is by using the Runge Kutta fourth order method. This is the error rate I am getting from here, from this Runge Kutta fourth order method. So if you proceed like this, the same thing. We have the terms like this. What is the step size? We have a step size like this. 0 plus this leads to this term. This term plus this term leads to this term. This plus this leads to this term. So on and so forth until 0.2000. So this process is repeated until the approximate y is calculated and it is compared and it is subtracted from the exact y to get the error rate. So this is how we are going to calculate. So in today's session, I just gave you the brief information how the formulas like K1, K2, K3, K4 are used to determine yn from or for an equation xn. If that is the case, y is equal to f of x. So yn is equal to f of xn. If that is the case, yn is equal to f of xn. This determines the value of this. Suppose if f of xn is equal to f of x is equal to x square minus 9, then we have to find out the value of k1, k2, k3, k4 for this to find out the value of yn. So this is how we are going to calculate. So in the next session, I am going to teach you about how we can find out the value of yn. That is by using the approximate method. That is using the Runge Kutta fourth order method. What is the exact value of that? If the predicted value is subtracted from the exact value, we will get the error rate which is through the Runge Kutta fourth order method. So with this, I am going to conclude my session. That is the same thing is explained here till 0.500. So with this, I am going to conclude my session of Runge Kutta fourth order brief method. Briefly, I am explaining this to you. In tomorrow's session, you will learn about the Runge Kutta fourth order method with a solved examples. The tabular representation was shown to you in today's session. In tomorrow's session, I will show you as to how you can find out the solution for an equation using a Runge Kutta fourth order method. Thank you very much. Thank you one and all.